The first modification we want to talk about is a lubrication mod, and it involves this hole right here. This is the lube hole for the direct drum bushing. All right, and go down through there. I think the hole might be a little bit smaller than a 3/16, so let me start by boring this one out just a little bit. There we go. And then I'm just eyeballing it. I'm going to try to, go as close to right down the center as I possibly can, and then just start drilling until it comes out the other side. There we go. Now what I want to do is chamfer the outside of these holes a little bit. Okay, I've installed my countersinking bit, and all I want to do is just barely tap that hole. I just want to put just a slight chamfer, that's all. That's good enough. I'll do the other side. Okay, that looks pretty good there. Now, many racing builders find that there is an area that you might have a possible problem, and that is where this roll pin goes. Remember, this roll pin is holding back the priming valve and spring. I think what can happen, there's been some documented cases where I would think something along the line of a pressure regulator that jams momentarily and suddenly the pressure goes to, like, 500 pounds or something, and it overwhelms that valve. It is pushing so tight against that spring that it actually breaks that roll pin. It's just 1/8 of an inch after all. And of course, if that comes flying out, you lose all your pressure and you're not going to be racing anymore that day. Now, although I think that's pretty rare for that to happen, it's worth making a slight modification here. Now, what most builders do is they simply take a 1/4 inch pipe tap, and thread this end of the bore, and then they use a 1/4 inch pipe plug and just simply go in. They run it into about the depth of where that roll pin goes. Now, what I'm going to do instead, I think, is a little bit simpler, and it should work just as well. And that is, I'm going to take that 1/8 of an inch hole and drill it out to 3/16. By drilling it out to 3/16, I can use, of course, a 3/16 roll pin, which is way stronger, and I'll guarantee you, you're not going to break that, cause that valve to come flying out with that. And there's enough material on the pump to accommodate the larger hole. Now, this really should be done on a drill press. I believe you can do it. I'll do it with the hand drill. I'll just be real careful. I want to make sure, again, I'm going to use a new bit, because if I use an old bit, you may start wallowing out the hole, and then of course the pin won't hold very tight. So let me do that. I'll just do it on the floor, and we'll get that accomplished right now. There you go. Okay, there's a couple other mods I want to talk about, and one is this passageway right here. This passage goes down to this little hole here. This is the feed hole for the torque converter. Now, most racing transmission builders feel that hole needs to be drilled out to 1/4 of an inch. Well, it just so happens that this pump housing, along with another one that I had checked, I found that this hole that goes in this direction is already about 1/4 of an inch, or the other one was 15/64, which is just 1/64 of an inch away from being 1/4 of an inch. However, the intersecting hole, this one right here, that's only about 1/8 of an inch, and I guess that one really should be drilled out. But here's the problem. You're not going to be able to drill it straight, because with a normal length drill bit, your chuck on the drill motor is going to be interfering with the stator support. You won't be able to drill it straight. So you only have two options. You either get a long shank 1/4 inch drill bit, which is available, I don't have one, or remove the stator support. Well, I don't need to take this stator support out, so I don't really want to take it out. Certainly, if I was going to replace it, it would make sense to go ahead and make that modification. It would be silly not to. But because I don't need to do that and I don't have the long drill bit, I think I'm going to let that go. That's not to say that at a later time, just before we fully assemble this transmission, I may acquire one of those drill bits and I may go ahead and pull it back apart and make that modification. Now there's one other mod I want to talk about, and that's this lube hole here. This is the lube hole for your front thrust washer. Now most builders feel that hole needs to be drilled out about 100 thousandths of an inch, or at least maybe 110 thousandths of an inch. But 100 thousandths of an inch drill bit, that is a very, very small drill bit. I feel that there's a bigger potential problem of breaking the drill bit off in the hole than the benefit you would get from extra lubrication. Because think about it for a second. When you're in a race application and your direct drum is laying down on that number one thrust washer, on hard acceleration, of course, the drum is driven back to the back of the case or toward the back of the case. And you will actually have an air gap between the thrust washer and the drum. So therefore, I don't feel that that is really super critical there. Robert says he's never really seen, a really heavily damaged thrust washer. I think the potential of breaking the drill bit off is greater than the amount of benefit you would get from extra lubrication. There's also a side problem too, and that is when you drill down through there, you can't drill all the way through or you'll wind up coming out through the stator support, which you don't want to do that. You only want to drill far enough to get into the cavity that's between the pump housing and the stator support. And because that's kind of captured in there, there's always a chance that little metal filings will fall down in that little cavity where you can't see it, and no matter how you blow into it and everything, you may not be able to get all of those shavings out. And then later on, when you're racing the car, then a couple of those shavings may come flying out and then you wind up damaging the thrust washer anyway. So I'm going to let that be. Okay, before we start reassembling this pump, there's one more little facet I want to talk about, and that is in the early days when people first started using Powerglides to go racing, they would use a torque converter from a Turbo 400. Now, the earlier Turbo 400 converters, both stock ones and racing ones, had to have a support for the input shaft. And what you had to do, you had to have the stator support machined to take a bushing in there, and that allowed the input shaft to be supported. But that created kind of a restriction for the fluid to return back to the pump. You had a nice unrestricted flow to get into the torque converter, but then as the fluid had to return back to the pump, that area where that bushing was created a restriction. So they felt like, why not make it just like a Powerglide converter? And that is, instead of having a bushing here, you had that support on the inside of the converter that supported the input shaft. That way you could do just like the normal Powerglide input shaft, and you have plenty of room there because there's no bushing. So that's the way all of the converters are basically made now. And the fact is, unless you had an old converter that somebody gave to you, I would say, don't even worry about the bushing setup for a Turbo 400. Use the more modern converters that have the support bushing built into the converter. Okay, it's time to put the pump back together, but before we do, I have a little confession to make. I said I wasn't going to be concerned about enlarging that torque converter supply hole, but I got to looking through a couple pumps that I'd gotten from Robert a few weeks ago that had some damage, but they were salvageable, and I discovered that both of those pumps already had that enlargement modification done to them. So even though these pumps were just normal rebuilt pumps, I think one of them, he said, was supposed to be for high performance use. None of the other mods had been done to the pump, but the company felt strongly enough about enlarging that supply hole. I've got to believe that that's pretty important. So I looked through my old junk drawer that I have a bunch of old drill bits, and I discovered that I had a 6-inch long, 1/4-inch drill bit in stock. So I decided to go ahead and make that modification. One thing you need to remember, when you do drill down in there, don't drill too deep. If you go too deep, you're going to wind up coming out the back end of the pump here, and of course you would, ruin it. You only need to go down about 800 to 850 thousandths of an inch. So I put a little paint mark on there, so when I drilled down, I could make sure that I wasn't going in too deep. Cleaned it all up, blew all the shavings out, and now it's time to, reassemble the pump. Okay, the first thing we'll do is put the priming valve and spring back into the back half of the pump housing. Now, when I drilled this roll pin hole out to 3/16, I inadvertently created some burrs on the inside of that bore. So I had to take a small round file and kind of dress it up a little bit, then blow it all out before I was able to get the priming valve in. Now, when you install the priming valve, the little tit side goes in and the hollow side faces out. And I just stick it right in the hole. Then I'll take my magnet, go in here, and what I want to do is check, make sure it's nice and loose, so there's no problem at all. That shouldn't have any concerns about it sticking. All right, now I'll put the spring in, and now I have to push that spring in with the blade of a screwdriver so I can start my roll pin. Here's my roll pin. Now this one happens to be about 1 inch long. You don't want it longer than 1 inch, and you don't want it less than 3/4 of an inch. If it was much longer than 1 inch, it might stick up a little bit too high and it could interfere with the drum that's in this location. So let me push the spring in deep enough with the screwdriver so I can get the roll pin started and have the spring behind that roll pin. So let me do that. Okay, be careful when you get toward the bottom and make sure that the spring doesn't get caught underneath. There you go. All right. That's it. It's just a little bit through, but it's not further than the straight edge of the bottom of the pump. That's exactly what I want. All right, let me make sure that the valve moves and it's nice and free, no problem. All right, let's work on the other pump half now. Okay, the pump gears that were in this pump were in good condition, but I decided to go with some new ones. So let's take a look and see how they're installed. Now, before we install these pump gears, we need to figure out their orientation. Now, this gear set is very similar to the ones that came out of the pump, and is typical of the replacement gear sets that you'll find. And on this one, the inner gear looks about the same on both sides, but with a closer observation, you'll find that the lugs here for the torque converter is almost flush on one side. However, on the other side, it's slightly countersunk. On those models, the countersunk side would face down, or in other words, toward the torque converter. On models where the countersink is about the same on both sides, that both of them have a slight countersink to it, they should have some type of marking on one side. On those models, the marking would face up. Now, on the outer pump gear, this one happens to be exactly the same on both sides. However, if you had one that had a marking, the marking would face up. Also, there were some models that had a chamfer on one side on the outer edge of the pump gear. On those models, the chamfered side would face down. Okay, let me squirt some transmission fluid down in here. You want this to be nice and lubricated. And we'll put the inner gear in, remember, chamfer side down. And then we'll put the outer gear and mesh that in. And it should be a nice, even fit. Very nice. Now let's put the back half of the pump on. Okay, the bolt holes that are used to bolt the two halves together have an offset to them, so there's no problem with the thing getting it out of orientation. You won't be able to do it. But let's make it a little bit easier on ourselves. We'll take and make sure that these two large cavities right here line up with the two large cavities on the back half. And you just, guide those two together, and it'll be a little bit easier to, find the bolt holes right there. Now I'll drop the bolts down in there. Remember, it's 5 bolts. We'll just do it finger tight right now. And when you get them in there, you'll see that you can move the two halves kind of independently of each other. So there's a need to get those two halves completely lined up perfectly. So there's a couple things we need to do. I'll take 3 of the regular pump bolts and just stick them through there in about 3 different places. That kind of lines those holes up. Now I need to make sure that the two halves are lined up with each other side to side. There's a couple ways you can do that. You can use a clamp that I made up here. I have one long hose clamp with one short one, the right diameter, and you can slide that over the two halves and then tighten it up. That'll get them lined up. Or you can actually take the pump upside down just like this and put it right down in the transmission housing, and the walls of that housing will line it up as well. Since I have this clamp, we'll go ahead and use it. And we'll just tighten it right on up. All right, and I'll torque these bolts down, and the torque spec is 20 foot-pounds. Okay, and the next thing I want to do is to glue the thrust washer in place. Put a little bit of Vaseline on the back side of it and stick that right in there. Remember, there's a little tab here that intersects with a slot that's in the back of the pump, just like that. Now I want to put the slip rings on. Now in your overhaul kit, you'll get 4 of these rings, so be sure you get the right ones. The ones for the pump are the ones that have the little hooks on them. The ones that have the little plain ends that look like small piston rings, those are for the governor sleeve in the back. All right, I'll just stick it right on. I'll just kind of carefully open them up by hand. You can use some snap ring pliers if you want, kind of help get it down in the groove. And once I get it in position, I'll put them on just like I removed them. I'll kind of push in on one side and take my thumb and kind of slide it around on the other side, and that should do it. See? Let me get the other one on. Very good. Okay, remember there's a large O-ring that goes around this pump, but we won't install that just yet. We'll just move this over to the side and bring our next component up, and that's the direct clutch drum assembly. Let's go ahead and disassemble it. First thing, we need to get this low sun gear off, and there's a snap ring that holds it in place, so you find where the opening is. Okay, notice the orientation of the snap ring. See how it's cut on an angle here? So if we go from this side, it'll come out a little bit easier. Get under it with a screwdriver, just like that. All right. Okay, we'll just lift out the sun gear, and it should be a little bit firm coming out. That's telling me, that the lugs are in good shape. They're not worn. All right. And you look at the back side, looks pretty good. Now right underneath that sun gear you have a thrust washer, and it looks pretty good. Then you have the direct clutch hub. Pull that out. Again, the splines, they look pretty good. Splines that go into the input shaft, that looks in pretty good shape. Underneath that you have another thrust washer, a real small one. That looks okay. And then you have the clutch pack. It's just easier just to flip it upside down and pull it out. And let's see what we have. Well, right on the bottom next to the piston, you have a wave spring, just like you see in the reverse clutch. Then you have a steel, fiber, steel, and boy, they're in pretty bad shape. A lot of material damage there. And all the way at the other end, you have another steel, and that steel rides up against the sun gear, just like that. Okay, now we need to get the piston out, so I'll use my homemade compressor this time to compress this retainer, get that snap ring out, and then we can remove the piston. Okay, I'll only want to compress that retainer enough to reveal the snap ring. I'll turn it around, find the opening, and I'll either use some snap ring pliers, or I think in this case I'll just use my hook tool to pull that snap ring out. There you go. And I'll take the compressor off now. And you have the retainer and a whole bunch of springs. Get those out. Looks like I have some damaged springs here. Not uncommon, especially when you have a lot of damage to the clutch itself. That means that most likely this piston kind of got over compressed and then damage the little return springs. All right, you have a seal here, and this seal is almost completely disintegrated here. We'll just take a pick tool and pull that off. There you go. And there's one on the inside of the drum down here, and we'll take the pick tool and get underneath that, pull it off. Okay, now we'll take all this stuff and clean it up. Okay, the part's cleaned up just fine. The drum cleaned up good, but remember we saw there was some damage on the drum where the band had cut into it. I believe if it was at the end of the season, I only had to make 1 or 2 races, I would certainly reuse this drum. But Robert had one that was in better condition, so we'll use that. Now the hub, again, in good condition. There's no damage on the splines, but remember that was one of the upgrades that we were going to do. I'm going to put a aftermarket racing style hub on, and I'll show you a little later on why you really need to use that. Not just for the strength, but you need it for another reason too. The piston, again, in good condition. You want to look down in here where the seal rides, and it looks fine. Now the return springs in the retainer, that's another story. The springs are completely destroyed and the back of the retainer is damaged as well. Now I have another retainer and some springs, so there's no problem there. All right, the first thing I want to do is remove the bushing from the drum here. And I can do that by taking this old socket. It's a 3/4 inch drive socket. It happens to have just the right wall thickness to go right down through the top of the drum here. I'll just put it on the floor and knock it out. Now the new bushing, I'll put that in using my bushing knocker tool. I'm using 2 mandrels on it. One of them is a 1 3/4 and the other mandrel is a 1 7/8. It happens to be just the right size what I need. I'll put the drum in the ram, in my shop ram, upside down, and push it in that way, because there's a little step on this side, so that'll let me go right down to the step and we'll stop flush with that step and it should be okay. Okay, I've got that bushing installed nicely against that back step. I'll go ahead and mount the drum on the pump, make sure it turns easy. That lets me know that there's no burrs on the bushing. Lastly, I want to check to make sure that that ball check that's in the bottom of the drum is still in there and that it's loose. And you can usually kind of shake the drum and hear it rattle. Looks like this one's okay. Okay, the next thing we want to do is to find out how to set this clutch drum up for a racing application. Okay, before we build this clutch pack up for a racing application, we want to make sure that we have the so-called long drum. And I think most of the 6-cylinder and 8-cylinder model Powerglides have the long drum. I think there were some 4-cylinder models that had a much shorter internal spline. They were designed for 2 or 3 friction plates and would make them not desirable for a drag race application. The round track guys, however, tend to seek those out because they're looking for less rotating weight and they actually want to have less plates in their transmission applications. Now, to make sure that you have a long drum, you just simply measure from that top ledge, the ledge where the sun gear plate rides, down to the bottom edge of that internal spline. And that measurement should be about 1 inch and 90 thousandths of an inch, give or take 5 thousandths. Also, if you drop your piston in, if it's a non-modified stock piston, if you measure from that same top ledge down to the face of the piston, you know, where your lower steel plate would ride, it should be about 1 inch, give or take 5 thousandths of an inch. If you get those measurements, then you definitely have the long drum. Also, you have to be careful. There were some very early model drums that had an oddball piston, and I understand that those pistons are really not available anymore, so you want to kind of shy away from those. But they would be, you know, pretty rare and very, very early model. Okay, in a stock application, you would have 4 plates and a wave spring. And when I say plates, I'm really talking about the internal spline fibers. In a race application, we want to have at least 5 plates or 5 fibers. So let's set this up and see what kind of measurements we get. We'll take the piston, drop it in there. Now, we're not going to put any seals on it this time because we're only testing. And then we put a steel in. Remember, we're not using the wave spring. And then we start alternating. Fiber, steel. And by the way, the fiber OEM thicknesses is about 100 thousandths of an inch, and the OEM steels is about 70 thousandths of an inch. All right, fiber, steel, and the last fiber, 5th fiber, and then we'll put a steel on top of that. Now, to find out what our clutch pack clearance is we take a measurement from that ledge, you know, the ledge where the sun gear plate rides, down to that top steel. And I'll do that by taking my caliper, putting it right on that ledge, and then pushing down and getting a reading. And I'm getting a reading of about 70 thousandths of an inch. I'll check it in 2 places. Check it on this side. And that's about 75 thousandths of an inch. So I've got between 70 and 75 thousandths of an inch clearance. That's a good reading. 60 to 100 thousandths is what we're looking for. Now, what if that clutch pack clearance did not come out right? Say I got 50 thousandths and it's too tight. How would I get it corrected? Well, there's a couple ways to do that. I can use a select fit top steel. They come in 70, which is stock, 60 thousandths, and a 40 thousandths. So between the 2 select ones, I should be able to get a spec reading that I want. There's another way of getting your clutch pack clearance in spec. That's to take your piston to the machine shop and have some material taken off of the face. Again, say I had 50 thousandths and I want 80 thousandths. You would have 30 thousandths taken off of the piston and you should get your reading corrected. And a lot of people like to do it that way because then if you had to rebuild it at a later date, you could use all OEM thickness of steels, and your clutch pack clearance should come out just fine. Okay, the question comes up, can you put 6 plates in, or 6 fibers? Yes, you can, but there are some consequences. Let's do that. We'll take and put a 6 fiber on top, and of course now we have no clearance. Remember, if we had 70 thousandths clearance before and I put 100 thousandths thickness fiber in there, I will have no clearance. So the only way to accomplish that is I would, in this case, have to take about 100 thousandths off of this piston. That would drop the whole pack down 100 thousandths and should give me that 70 thousandths reading that I had originally. But there's a couple problems there. That means that I won't be able to use a top steel. Instead, I use the bottom of the sun gear plate as the top steel. That's fine, but if you ever damaged your clutch and you tore up a bunch of the fibers and the steels got all damaged, most likely the bottom of this plate would also be damaged. You could reuse it, but not as a top plate. You would be forced to go back to a 5 fiber setup and then have a steel on the top. The other problem is, if you remember, when we said the distance from that top ledge to the bottom of that internal spline was 1 inch and 90 thousandths. Okay, now with this piston having 100 thousandths taken off of it, we went from 1 inch from that ledge to the face to 1 inch and 100 thousandths to that face. That means that your bottom steel is now no longer being totally supported on one of those internal splines. Part of the steel actually would be below where the spline quits on the drum. Is that hurting anything? Well, not so much, because when the clutch is in the rested position, of course, everything is just turning free. And then when the piston applies, what happens? It actually pushes up on that bottom steel, and then you will have full contact. But it seems to me that over time, as those, the piston is coming up on the 1-2 shift, it may create like a little divot on one side of these lugs, which eventually could maybe get caught on the bottom of that spline. I don't think that's very likely, but it is possible. And then you also have the added fact that you would eventually damage the bottom of the sun gear plate. Therefore, I feel that in most applications, certainly in our example application, 5 plates or 5 fibers should work just fine. And Robert has found that using the OEM clutches does real well. He's also used the racing style clutches. They do last a little bit longer, however. But in most applications for our, say, 500 to 600 horsepower setup, the OEM style clutches works just fine. All right, one more thing I want to say. Remember earlier I said that we really don't want to use the stock direct hub. Well, the reason is, if I take all of these plates back out and then just put the steel in and a fiber, and then put the little thrust washer on here, then take the OEM hub and lay it down in there, I find that the hub just barely catches the teeth on that internal spline friction. Why? Because remember, in a race application, we're not going to use that wave spring, and the wave spring, brought that first fiber up a little bit. Now the fiber is a lot lower. Plus, if I wound up taking some material off of this piston, guess what? The fiber is lower yet, and maybe so much so that it would not even catch on the stock hub at all. So therefore, the racing hub is really a must, and you can see, obviously, it's longer, and it would catch, even if you took a right much material off the piston, it is long enough to catch that bottom fiber. Okay, now I'll take these clutch fibers and put it in my little pot with some transmission fluid, let them soak for 20 minutes or more, and we'll get this drum set up for reassembly. Okay, the direct clutch uses lip type seals, and to install those we want to first get plenty of transmission fluid down in the drum and on the piston, and we'll install the outer seal first. Okay, we'll put the outer seal on first, and all you need to remember is the lip side always faces down. So we'll just get it started in the groove here and work our way around. There we go, just make sure it's in the groove. May have to work it just a little bit. There you go. All right, the inner seal goes inside the drum, and again, the lip side goes down. What you'll do is go beyond the ridge here, and then you'll have to kind of come up on the seal to get it to go into the groove. Okay, I think I got it all nice and seated. And now what I want to do is to put the piston down in there. Now the inner seal is not going to cause a problem because it's already facing down. It just simply will ride up into this cavity. However, the outer seal will want to hang up on the outer edge of the drum. There is a slight chamfer there, but to be able to get that lip in there, we'll need to kind of help it along. And I can use either that little wire tool that I bought, or the one that I made, or maybe even a 10,000ths feeler gauge, and just carefully, you know, put it in place and then just work the edge all the way around until it finally gets by that ledge of the drum and slides in. All right. There you go. Sometimes it takes a little finesse, and it's easy to damage that outside seal, so be careful. Looks like we're okay here now. Okay, now we'll take the 24 little springs and stick them on the piston. I take a little bit of Vaseline to glue them in place, hold them in place. Okay, now I'll put the retainer on. Then take my compressor, compress the retainer, and install the snap ring. Now remember, there's another snap ring in the transmission on the reverse clutch, and that one is just a little bit smaller in diameter than this one. Okay, be careful when you're compressing this retainer and make sure it doesn't get hung in the snap ring groove. Okay, I'll get it in here. Usually you can just do this by hand because the snap ring is so small. There you go, and now I'll take the compressor off. All right, let's put this clutch pack together. The first thing I want to do is to put that inner thrust washer, then drop on my new clutch hub, and then put the steels and the fibers in. Now remember, this one will have 6 steels and 5 fibers. And of course the fibers have been soaking in transmission fluid. Make sure all of this is nice and lubricated as you go back together with it. And the last fiber and the top steel. Now I'm going to check the pack clearance again, because sometimes when these fibers soak in fluid, they swell just a little bit. And it looks like I still have about 70 thousandths. All right, and then I'll put the outer thrust washer right there in the middle. Again, make sure I got plenty of fluid on it. And then drop on my sun gear and its plate. Now understand, this sun gear is different than the one that came out of this transmission, because I'm going to put a 176 planetary in, so I needed to have a compatible sun gear. All right, and then I'll put the snap ring in, and remember, you have to put this side of the snap ring in first to make it easy to install, and you should be able to just do this by hand. And may need a screwdriver to get it in. There you go, just popped in. Okay, before we leave the direct drum, let's do an air check. We already have the pump laid out. We'll go ahead and drop the drum down onto the pump. Be very careful, you don't want to break those slip rings. Okay, now I have to introduce air into this hole here, but to keep from having an air leak, this elongated hole must be covered up with my finger. Okay, I have a little vacuum hose around my air blower to kind of keep from losing so much air around the hole. And let's see if we can hear that piston engage. Yeah, it sounds good. Definitely hear that piston going in and out. I think we're in good shape. Okay, the next component we want to talk about is the reverse clutch, the clutch that's housed in the transmission case. Now, if this transmission was going to be just a manual shift transmission, I would just simply reinstall the reverse clutch along with the wave spring and be done with it. But because this transmission is going to be using a trans brake, we need to pay a little closer attention to how that reverse clutch pack is built up. Now, this particular transmission had a four plate unit. In other words, it had four fibers along with the wave spring. Now, in a trans brake application, we're going to do away with the wave spring, and we should be able to just reassemble it without the wave spring and still get 4 plates. 4 plates would be the minimum that you would use in a trans brake setup. Now, some Powerglides came stock with 5 and even 6 reverse plates, if you happen to get a unit like that, where you're in luck. But even if you don't, there is a way to add clutches. What we'll do right now is simply take the stock piston and drop it down in there. Remember, we're just testing, so there's not going to be any seals put on it. And let's build up the clutch pack and see what we come up with. Okay, this parking paw might be in the way, so let me flip it up so it doesn't interfere with installing the piston. I'll take the piston, simply drop it down in here until it bottoms out in the case. All right, and now let's put a clutch pack together. Okay, I'll install a steel plate first, and you need to know these steel plates are indexed. They only go one way. So what you want to do is find the lug that has a little notch on it right here. That notched lug goes in the 7 o'clock position slot that's in the case. Now, because the case is upside down, that slot is in the 1 o'clock position. So let's go ahead and install a steel. If you have a little trouble and the lugs don't line up, then it's just simply backwards, and just flip it around. Okay, now I'll put a fiber in. Put another steel in. And a fiber, and I'll keep going until I get 4 fibers in. Okay, now that's the 4th fiber. Now I want to check my clutch pack clearance. Now there's a little ledge in this case, just like there's a ledge on the direct clutch drum. And what I want to do is to take my caliper and measure from that ledge to the face of the clutch fiber and see what kind of measurement I get. All right, now I'm getting, well, it looks like 175 thousandths of an inch. Now the spec that I'm looking for is 90 to 120 thousandths, so I've got a ways to go. Let's see if we can put another steel in there and measure again. Okay, this time I've got, oh, looks like about 97 thousandths. So I am in spec. I could easily mount the pressure plate in position, put the snap ring in, and I'm ready to go. Now, by the way, if your clutch pack clearance didn't come out exactly right, there are some select fit steels available in which you could make slight adjustments to your clutch pack clearance using those. Now, the only way to get more clutches in this pack is to go with a thinner clutch piston. Now, this happens to be another stock piston I had in stock, and I put it on a brake lathe and actually took some material off. Now, if you remember, we got a clutch pack clearance of about 100 thousandths on that last steel. So I should be able to put another fiber in there, and remember, the stock fibers are 100 thousandths of an inch thick. So if I took 100 thousandths off of this piston, I should be able to install that, put 5 fibers in there, and I still should maintain that 100 thousandths clearance. Let's give it a try. Pull the clutch pack back out. Take the piston out. I'll put the modified piston in. Put the clutch pack back in. And I'll add a 5th fiber, and I'll take a measurement. And I get a reading of, looks like about 105 thousandths of an inch. I would say that would be fine. And I think the 5-plate setup is what we'll go with on this project. Let me pull this back out. I'll put the fibers in my pot that has the transmission fluid, let that be soaking. And by the way, I have another piston right here. This is one that Robert made, and he took some even more material off of this one, and this one is set up to take 6 fibers. I've tested it previously, and I found that it does work just fine. Okay, now understand the transmission you're working on may have slightly different dimensions than the one that we have here on the table. So when you're setting up your clutch pack clearance unit, you may come up with slightly different numbers, so be mindful of that. Now, because some Powerglides came with a 5 or 6 plate reverse clutch pack, there's no problem modifying one to take more fibers. After all, the transmission case has grooves that are deep enough, and the ring gear splines are long enough to accommodate a 6 plate reverse clutch pack, no problem at all. I think now I'll take the modified piston, I'll put the O-ring seals on it. This uses square cut seals, and I'll set this aside and we'll go on to the next part of the project. Now this transmission is going to have a trans brake valve body. However, earlier I said I would take a regular stock valve body, change it over to a manual shift valve body by using one of the available kits. So I have the 2 halves disassembled here. The separator plate is here on the table, and I have 2 of the valve assemblies out. This is the pressure regulator, and this is the shift valve. Now, to change the valve body over to manual shift, you really only need to do one thing, and that is you have to put the shift valve in the upshifted position. This kit accomplishes that by putting this little spring on the end of the small end of the valve right here. What that will do, that will move the valve over and position it in the upshifted position permanently. So anytime you're in the drive range, it will always be in high gear. However, if you put it into manual 1, fluid is redirected and you will always have the manual 1 position. All right, but that only changes the valve body to manual shift. It does nothing to firm up the shift. And for a race application, of course, you want that shift to be nice and fast, good and firm. So 2 more things have to be done. 1, the line pressure has to be raised. So this kit accomplishes that by removing the stock pressure regulator spring and installing their spring, which is much stronger. All right, that raises your pressure, which that's good, but now you need to take some of the restriction out. The fluid path going to the direct clutch needs to be straighter and have less restriction. So this kit accomplishes that by taking the separator plate and drilling out 2 holes. One in this location here, and the other in this location. In fact, the kit comes with the drill bit that you need to accomplish that. Then it's just a matter of reassembling the valve body, all with the stock parts. You need to put the modulator back on. The vacuum hose does not need to be replaced, but all of the other parts need to be put back on for the simple reason that it's covering up holes, even though some of those valves are not being used. Now, some kits will be made slightly different. Instead of having a stronger pressure regulator spring, it may come with a shim that will go on the spring to tighten it up. Some kits may have their own separator plate, which is already pre-drilled to accomplish all of the aspects as far as reducing restriction. And I would say, you know, with this kit, you just simply put, you know, a couple new gaskets on, put the two halves back together, bolt it up. I think the torque spec is 15 foot-pounds on those bolts, and simply reinstall it in the transmission. Okay, now it's time to do modifications to the case and get it ready for reassembly. First thing I want to do is to work on the extension housing. I've already pried the seal off. I just simply chucked it in a vise carefully, used a long pry bar, knocked the seal out, and now I want to remove the bushing and replace it. I'll use this mandrel here. I found that a 1 5/8 mandrel is just the right size to push it out. I'll just put it on the floor, knock it out, and I'll use my bushing knocker to put the new one in. Alright, I'll go ahead and put the seal on. Okay, I put a little bit of Vaseline on the inside here to protect that garter spring, keep it from popping out. And just tap it on. Alright. Now, because we're not going to have a speedometer gear hooked in, I'm going to put a freeze plug in the speedometer gear hole. It's a uses a 7/8 freeze plug, so we'll go ahead and put that in now. Okay, you could put just a little bit of sealant around the freeze plug. I'm going to go ahead and put it up dry. I think we'll be all right. I've got a socket that fits it pretty good, and I'll just knock it down a little bit past the flush position. Okay, the next thing I want to do is remove that broken plastic vent in the case and replace it with a metal one. I've hammered a small easy out into it, and I should be able to just unscrew it. I'll run an 1/8 inch pipe tap in the hole and go in there a little ways with the pipe tap. Alright, I'll blow down the hole with a little compressed air, get the filings out. And then screw the new metal vent in. It's usually called, some people call it a jiggle pin. And I'll just thread that in place. There are some classes of drag cars where you need to have a nipple here and a hose going to a little puke tank in case the transmission overheats and blows fluid out. I think for this project we'll just use this jiggle pin. Alright. Okay, next I want to replace that case bushing in there. Now there's a couple bushings that will come in your kit that are about the same size. Of the two bushings, the one that's slightly longer, that's the one that goes in the case. The other one goes in the governor support. Okay, I've put the case on the floor. I'm going to use the bushing knocker that Robert made, and I'll knock it out from the back. Get the old bushing out. Now flip the transmission around. It's on a couple blocks of wood. I'm going to take the bushing and install it from this side, and I want to countersink it in the hole here in the case about a 1/16 of an inch. So I'll take my little installer tool, try to make it as straight as I can, as straight up and down as I can, so the bushing goes in good and square. There you go, it's countersunk about a 1/16 of an inch. That's what I want. Okay, now off camera, I put that slightly smaller bushing into the governor support. Used the same tool, and I made sure that the bushing was flush with this back side right here. Okay, now we want to make some modifications to the back of the case, so let's take a closer look. Now, if this transmission was going to be used just with the manual valve body, no modifications need to be made back here. However, if the transmission was a dual pump model, we need to modify it to a single pump configuration. The first thing you would do is this hole right here would have to be tapped with a 5/16 18 thread tap, and then put a set screw in there. You may have to put just a dab of Loctite on it, run the set screw in past flush to block off that hole. Then you would have to go down to this hole and drill it out. All you really need to do is use an 1/8 of an inch drill bit and drill all the way through the case. That would change the dual pump model to a single pump configuration. Also, you would need to obtain a single pump style governor support to go back here. Now, this transmission will be using a trans brake valve body. So I'll show you the mods that are needed to use a so-called full tree brake. Now, a little later on, I'll show you the extra mods that's needed for a pro brake valve body.